In this one, let's take a look at forming a power series. So I'm going to begin with this basic fact that 1 over 1 minus x equals the sum from n equals 0 to infinity of x to the n. And the values of x that make this, or the two sides equal, have to be such that x lies between negative and positive 1. Keep that in mind, okay? That's what this means, this inequality. What we're going to do is make use of this fact and form a power series for this quantity right here. Take a look, 1 plus 1 over x squared. So the first stage is to rewrite this in its equivalent form. And you want to do that so that you can make it look like this, like step 1. So you can do that by saying 1, and then the plus can be written as minus a negative x squared. Now that you have this negative x squared identified, you can plug it into that pattern. That's all. And notice that here, it's important to remember a basic fact. When you have a positive, you can rewrite it as minus a negative. And now you can simply proceed as follows. I'm going to say here 1 over 1 minus negative x squared. That will be equal to, you take your summation symbol, you keep the top and the bottoms, so from 0 to positive infinity. The only difference is where you see x, you replace it with negative x squared. That's all. So you're going to put negative x squared in this position. And also make sure you replace it in the inequality. You want to replace it everywhere. So it's going to give you negative x squared less than 1. So I'm replacing this in this position, but also in the inequality everywhere. At the next stage, I'm not going to copy the left side because it takes too long. I'll just work out the right side from here on. So I'm going to say the summation symbol, n equals 0 to positive infinity. Here I'm going to break this into negative 1 times x squared to the n. Same thing over here. This is really negative 1 times x squared less than 1. Continue here at step 5. Now I'm going to say n from 0 to positive infinity. That's negative 1 to the n. And then times x to the 2n. Back at step 4, when you have that n, you can distribute it to the negative 1 individually, and you can distribute it to the x squared individually. In the inequality where you have negative 1 x squared, there's a basic rule of absolute value. You can distribute the absolute value bars to each factor when you're multiplying. Negative 1 and x squared are being multiplied. Negative 1 is a factor, x squared is a factor. Therefore, over here I can say negative 1 in absolute value times x squared in absolute value less than 1. Let me separate this out so you don't get confused here. Step number 6, therefore, I can say the following. From 0 to positive infinity of negative 1 to the n times x. And remember here, when you do this portion back at step 4 where I wrote you distribute the n to the x squared, that's what gives you x to the 2n. That's why that is present. So to the 2n, the negative 1 in absolute value goes away. When you have the absolute value of a square, you can just drop the absolute value bars. That is so because remember, when you have this kind of calculation, imagine you have this for a second as a small side note. Imagine I gave you negative, for example, 2, and I square it and I take the absolute value. Well, keep this in mind. When you square something, it turns positive already. You don't need the absolute value bars, you see? Because that squaring makes it positive. So for that reason, you can just drop the absolute value bars. Therefore, in our case, where you have x squared, you don't need absolute value bars around that for exactly that same reason. Then you can just find the following. So n goes from 0 to positive infinity of the negative 1 to the n times x to the 2n. And here, just rewrite this portion. That's a side step. I'm going to try to work it out this way for you. Take a look. I will say that this is equivalent to x squared minus 1 less than 0. Then this is x minus 1. You're factoring using difference of squares on the left side in case it's been a while. And now you can solve this inequality by doing a simple number line. Again, I'm showing you this in case it's been a while for you. 0 in the middle, negative 1 over here, and then positive 1 over here. Because it says less than, you have to go and then choose the values. In our particular case, take a look. If you plug 0 in there, that will work. Take a look. You're going to have 0 times 1 times 0 plus 1. Is this less than 0? That's the check here, okay? Well, negative 1 is what's left over. Then you have here positive 1. And then lastly, negative 1 times 1 is negative 1, which is less than 0. So this checks, which means the interval that is correct is the one that goes from negative 1 over to 1. And all the values in the middle are the right ones. That would be the interval of convergence then, for example. Do keep in mind that for this kind of power series, the -1 and the 1 themselves are not included. And you can check, for example, if you plug in -1, you will have -1 minus 1, and then you'll have -1 plus 1. Is this less than 0? No, it isn't, because this here is -2, but -1 plus 1 is 0. So when you multiply, you will have a 0 less than 0. That's a contradiction, right? That is false. And the same thing applies if you plug in, for example, +1. So the interval of convergence basically is represented right here with the number line, and the final representation is this one right here. And that is it. Thanks so much.